All right, it's finals week, right? It's the last week of the 2019-2020 school year for Manor ISD. So, in theory, we'd be doing finals this week, but instead we're continuing to learn. Last thing we're going to learn, though, for my geometry classes are surface areas and volumes of spheres. So a few vocab words we're going to see: great circle, pole, and hemisphere. So the great circle is a circle that goes completely around a sphere right through the middle. The pole would be like the pole that goes from north to south pole on the Earth, and the hemisphere, just like on Earth, is just half of a sphere. So surface area of a sphere is equal to 4 pi r squared. So that's the formula we're going to use for the first few problems. So our first one here is the surface area of a sphere. We're going to round to the nearest tenth, and we can see given to us is the radius. So we're good to go. So our surface area of our sphere is equal to our formula, 4 pi r squared. 4 pi times 4.5 squared. And at this point, as with anything with pi involved, easier just to go ahead and plug it in the calculator. So our surface area of our sphere, round to the nearest tenth, is 254.5 square inches. Now our next one is a little bit different. Now we are given a hemisphere. So again, a hemisphere is half of a sphere, so all that means is we just have to divide our formula by 2. So our surface area of a sphere, again, is 4 pi r squared. So the surface area for a hemisphere is 4 pi r squared divided by 2. When we do that, the 4 divides by 2, we get 2 pi r squared. So here we are given our radius again. So our surface area for our hemisphere is 2 pi times 3.7 squared. And our solution, after again going into the calculator, is rounded to the nearest tenth. Again, it doesn't say that to do that here, but I get an even 86.0, which means probably rounded. I don't have the full calculation in front of me, but it's millimeters squared. So now our next one, even then, is going to change it even more. So the surface area of the sphere of if the circumference of the great circle is 10 pi feet. So we were given a circumference calculation for the great circle, and we want to find the surface area of the whole thing. So there's a couple ways we can approach this. We can take the circumference, work backwards and find the radius, and then work forwards and find our surface area. Or we can come up with a new equation that involves the circumference of the great circle. So kind of both ways of doing it. So the first way is just to take our circumference. Again, that's 2 pi r. Our circumference here is 10 pi. And just dividing both sides by 2 pi. It's actually pretty simple because everything works out nicely. Our radius is equal to 5 feet. So now we have a radius, we can go ahead and find our surface area. 4 pi r squared, or 4 pi times 5 squared. 5 squared is 25, times 4 is 100, so it's 100 pi. We had this calculation on the last video. Different situation, but now it comes out to be the same number, 314.2, and here are units feet squared. So that's the way to do it when you work backwards to find the circumference and then find the surface area. Now we can manipulate our equation for the surface area as well. So our surface area, again, is 4 pi r squared, right? But we do know that circumference is 2 pi r. So if we divide that out, we get 2 pi r times what's left. We have a 2 left and r. So that would mean we would multiply. Now, again, here we don't know our radius, so it's not exactly the easiest way to do that, so it doesn't help too much. But we could also work a different way instead of doing it that way. If we square the circumference, so it's not equal there, we get 4 pi squared r squared, right? So the only difference between these two formulas is that pi is squared. So if we take the circumference of the great circle, 10 pi and really we don't need to use that yet. Hold on. Having a little bit of a brain fart here. So we know that the circumference is equal to 2 pi r. And in this case, we're looking for what the radius is, unless this is just the general form, right? Ignoring what our actual circumference is. So it's or circumference over 2 pi is the radius. So then if we take that and we plug it in to the formula here, so let me erase some more. Sorry, I'm having some difficulties here. 4 pi times our new formula for the radius, circumference over 2 pi squared. So that would mean we square everything inside that parentheses. So 4 pi times circumference squared over 2 squared is 4, and pi squared. So now we can simplify some things. We've got a 4 outside and a 4 on the denominator. Those will go away. And 1 pi on the outside and 1 pi underneath go away. So we are left with our formula for surface area of a sphere given the circumference of the great circle is just the circumference squared over pi. So now let's plug in what our circumference is. It's 10 pi, right? So 10 pi squared over pi gets us 100 pi squared over pi. Again, the pi on the bottom and one of the pi's on top cancel, and we have 100 pi, which comes out to be 314.2 square feet. So this one seems complicated going that way, but once you have that formula, that the circumference of the great circle squared over pi formula, then really it's not that bad. It's just the process of getting what that formula is. Now that we have it, we could use that over and over again as many times as we need. So here we are given the area of the great circle. This one's different, right? So again, we can work backwards, find what the radius is, but there's an easier way to do it once you have the formula that cooperates with it, right? So we know that the area of a circle is equal to pi r squared. So if we work backwards, we're going to divide by pi on both sides. Not work backwards, solve for the radius, that is. And we square root. We end up with the radius is equal to the square root of the area over the radius. Not the radius, over pi. So now we have our formula. So now what we want to do is we want to find the surface area of the sphere, which is 4 pi r squared. So we plug in our new radius equation, just like we did before. Square root of the area over pi. Now typically I wouldn't leave it like that, but I know what I'm about to do is square it. So that cancels out my square root. And now I have this pi and pi thing that goes away. So now what am I left with? Let's look. Everything else is canceled out. The 4 is still there. And we have this a. So it's literally just 4 times the area of the great circle. So our surface area of our sphere is equal to 4 times 220, or 880 square meters. Again, you can work backwards and find it that way and find what the radius is approximately and then work through it and square it and all that. But this gave me an exact answer because I used what I already was given. As exact of an answer as I can get. That area is approximately. So it's not entirely true, right? So if we wanted to find our radius, we would just plug in this formula. That'd be 220 divided by pi and the square root of that, which gets us about 8.37. Then we would plug that back in to the surface area formula for a sphere, 4 pi times 8.37 squared. And again, that 8.37 is approximate, so I wouldn't really round until I'm done. I would just round it for the writing purposes, but plugging that in again gets us the 880 that we got right there. So there's the way you would do it typically, but if you find this formula, if you now know that if we are given the area of our great circle, all we got to do is multiply by 4, and that's going to give us the surface area of the sphere. It's kind of a cool little twist, right? So now we're going to shift gears. We came up with those equations, and now we're going to not use them. Well, you will, but I won't right now. The volume of a sphere is 4/3 pi r cubed. So let's take a look. So our first one is now giving us the circumference of the great circle. So again, we can work backwards, find our radius in that way, or we can use that formula and come up with a new formula that works every time. It's up to you. So I'll show you both ways again. So the circumference again is 2 pi r. The radius again is the circumference over 2 pi. So now we have that. Again, our formula for the volume of a sphere is equal to 4/3 pi r cubed. Now, this one kind of gets ugly because we're cubing, but it's not too bad. So it's going to be 4/3 pi times our circumference over 2 pi cubed. So when we cube that, again, we cube both numerator and denominator. So we have 4/3 pi times the circumference cubed. 2 cubed is 8, and pi cubed. So once again, the pi on the outside is canceled. The pi inside becomes pi squared. The 4 and the 8 simplify to 1 and 2. So now multiplying across, we have 1 times c cubed, so the circumference cubed stays as our numerator. And our denominator is 3 times 2 pi squared. So that's going to be 6 pi squared. So that is our new formula that we're about to use. So the volume of the sphere, in this case, is going to be 30 pi cubed over 6 pi squared. Three cubed is 27. So 30 cubed is 27,000 pi cubed over 6 pi squared. Once again, we have some pi's that will eliminate. 27,000 divided by 6 is a nice even 4,500. So we have 4,500 pi is our answer, or says to round to the nearest tenth again, and that is 14,137.2 centimeters cubed. Now, again, we could have gone the other way and found out what our radius is, right? The radius is going to be our circumference over 2 pi, so 30 pi over 2 pi, which again is a nice easy number to use, unfortunately, for my finding the new formula argument. But it's 15 centimeters. So then we plug that back into our formula for volume of a sphere. 4/3 pi times 15 cubed, and you do indeed get that answer above it. But again, at that point, you're pretty much just going to plug in the calculator, and the way we did it, there's more breakdown, right? But there's also no need to find another thing first. Now that we have the formula, c cubed over 6 pi squared, every time we're given the circumference of the great circle, we can use that formula. Now we have a hemisphere, we are given the diameter, so we're going to use our normal formula for this one. But we do have to do one tweak because we are looking for the hemisphere. So again, volume of a sphere, 4/3 pi r cubed, but the volume of a hemisphere is going to be 4/3. I'm going to write it a little bit differently. 4 times pi r cubed over 3 over 2. So when you are dividing fractions, remember you got to keep change flip, right? So you're dividing by 2, but you're really going to multiply by 1/2. So 2 times 3 gets us 6. So this is going to be 4/6 pi r cubed, which simplifies. 3/2 pi r cubed. So now we have our new formula for the volume of a hemisphere. This time now, though, we are given the diameter. And that's an easy thing to deal with. Diameter is just, radius is just the diameter divided by 2, or 6 over 2, so it's 3. So now we're ready to go. 2/3 pi times 3 cubed. 3 cubed is 27. So it's 2/3 pi times 27. 27 divided by 3 is 9. So that's going to be, and then 2 times 9 is 18, so this is 18 pi. And now we're ready to just plug in the calculator. It does say it around to the nearest tenth. So our volume of our hemisphere comes out to be 56.5 cubic feet. We have one problem left to look at. So this one, the stone spheres of Costa Rica were made by forming granodiorite boulders into spheres. One of the stone spheres has a volume of about 36,000 pi cubic inches. What is the diameter of the stone sphere? So now we're looking to go backwards and find the diameter. So now it's fine using the normal formula. We'll get the radius and we'll just double it. So the volume of the sphere is equal to 4/3 pi r cubed. Our volume here is 36,000 pi equal to 4/3 pi r cubed. So the advantage of having the pi there means that we can just cancel out the pi's. If we divide both sides by pi, they're going to go away. So now what we need to do is multiply both sides by 3/4 to get rid of the fraction. So we're left with just r cubed on the right side. And 3/4 of 36,000, so first 36 divided by 4 would be 9, so that'd be 9,000. And 9,000 times 3, so 9 times 3 is 27, so it's 27,000. And now we cube root both sides. Gets rid of our cube. And we are left with an r equal to 60. Or no, sorry, r is 30. So now we need our diameter. So that's, 30 inches. So our diameter, remember, is going to be 2 times our radius, or 2 times 30, or 60 inches. Have a good summer.